Welcome to the video on emitter coupled astable multivibrator. Before going to discuss this topic, we just make a recall about what is meant by astable multivibrator. The astable multivibrator has both the states as quasi-stable state. It has two quasi-stable state, so none of the states are stable state. This multivibrator automatically makes the successive transitions from one quasi-stable state to another quasi-stable state without any external triggering pulse. So the rate of transition from one quasi-stable state to other is determined by the circuit components. So overall, this astable multivibrator does not require any external pulse for the transition. So it is called as running multivibrator, and it is also called as square wave generator because it is used to generate the square waveforms. Now we are going to discuss about the circuit diagram of emitter coupled astable multivibrator. So this is a circuit diagram. In this diagram, two transistors are used, Q1 and Q2. So both the transistors are capacitive coupling, and the collector of the Q1 can be given to the input of the base of Q2, and the collector of the Q2 can be given input of the base of the Q1. So these two transistors are identical, and these two transistors are called as NPN transistors. Here we are using RC collector resistance, and RB is the resistance for bias provision, and here VCC can be given to the circuit. Now the collector of Q1 can be given input to the collector of Q2 through the capacitor C2. Again, the collector of Q2 can be given input to the Q1 through the capacitor C1. So let me see the operating principle of this circuit. Before that, we must know about the basic concept. If the transistor is on means what are the condition? If the transistor is off means what are the condition? If any one of the transistor, either Q1 or Q2, is on means what are the condition is? Suppose we can make an assumption at initially when the power supply is given to the circuit, the Q1 and Q2 is trying to conduct. So let us assume that the Q1 is on condition and Q2 is off condition. If Q1 transistor is on means the collector and the emitter terminal of Q1 can be short circuited. So the collector current of Q1 should be more, that is IC equal to IC saturation, and the voltage across the collector and emitter terminal of Q1 should be given as almost 0, that is VC saturation. If the Q2 is off, so in first condition Q1 is on and Q2 is off. If Q2 is off means the collector and emitter of Q2 can be open circuited, so the collector current is 0, there is no collector current in the junction, so IC equal to 0, and the voltage across the collector and emitter of Q2 can be given as VCC, power supply. So this is the first quasi-stable state. This is the first condition. In this condition, this emitter coupled astable multivibrator is in the quasi-stable state. So the emitter of Q1 and the emitter of Q2 can be coupled with the help of the resistance RE, that is emitter resistance. It can be grounded. So as per the condition, Q1 is on, Q2 is off. So if Q1 is on means the voltage across the collector and emitter can be almost 0, that is VC saturation. So that minimum current, that 0 current can be given to the base of Q2, that is through the capacitor C2. So that input current should be less than the cut-in voltage. The input voltage should be less than the cut-in voltage. So Q2 is automatically driven into off condition. So this is for the first condition. And next, so when this capacitor C2 is going to charge with the help of the VCC, so once the capacitive voltage reaches the maximum voltage value means, so that voltage can be given to the input of Q2, that is base of Q2. So that voltage is also greater than the cut-in voltage means this Q2 transistor can be turned into on condition. If it is Q2 is on means automatically Q1 is off. So if Q2 transistor is on means the emitter and the collector terminal of Q2 can be short circuited, and hence the collector current will be more. So IC equal to IC saturation, and the voltage across the collector and emitter terminal should be given as 0 or VC saturation. So now the Q1 is in off condition. So it is off condition. So the collector terminal of Q1 and the emitter of Q1 should be open circuited, and there is no collector current in this circuit. So IC equal to 0, and VC1, that is voltage across the collector terminal, VC1 can be given as the power supply VCC. So this is the second quasi-stable state of astable multivibrator. After some time, this capacitor C1 is start to charge. So here the plus sign in the left hand side and right side, and the negative sign in the right hand side. So the capacitor C1 is start to charge. Once the capacitor reaches the maximum voltage value, that voltage value can be given to the input of the Q1. So this capacitor voltage is more than cut-in voltage, and again it will trigger to start the conduction of Q1. So Q1 is on, and again Q2 is off, and this process is going on. So this is the circuit working principle of emitter coupled astable multivibrator. So here, as the name suggesting, it is called as emitter coupled. So both the emitter terminals should be coupled with together. So the emitter coupled astable multivibrator, which used to produce the square waveform, and it is also called as free running multivibrator. Thank you.